In this video I'm going to talk to you about probability tables, which are essentially two-way tables. Instead of putting the numbers in the two-way table, we put the probability in there instead. So I'm going to start by using the example where we had movies and football, which you would have seen on previous videos. So what we had was we had one set for the football matches and one for the movies. Okay, so I've pre-drawn that. Now what I'm going to do is I'm going to convert that information from the Venn diagram into a two-way table. F represents the football match, M represents the movies. So if I'm going to draw a two-way table, so this is just the two-way table, I'm not doing the probability table yet, I'm going to use the F for football. F dash is going to represent not attending the football match, M for attending the movies, and M dash for not attending the movies. Now with the two-way table, there's always totals. And we always total each column and each row, and then what we get in this corner is the total number of people that were in the sample altogether, or the survey. So let's have a look at the information in the Venn diagram. We've got a total of 22 people altogether who went to the football matches. So the total of people who went to a football match should come to 22. We've got a total of 25 that attended the movies. So this is the movies, total 25. Now within that, we've got the intersection of 12. That means people who attended the football match and the movies. Football match and movies joins together to make this spot here on the two-way table, so 12 goes in there. We've got only 10 people who attended the football match, not the movies. So attended football, not the movies, goes here, so 10 there. And that makes our total of the 22. 13 people here only attended movies but not the football match, so movies but not football goes here, and we have the 13 there, which then gives us the total of 25. We can then fill in the rest of the numbers by looking at other totals. We've got 15 people here outside of our circles that didn't attend either, not the movies and not the football match. So 15 will go in there. Add those together and we can complete the rest of the two-way table just by totaling. So these two will total that, which is 13 plus 15, which is 28. 10 and the 15 give us the 25. Add these two together gives us 50 here. And then what we should find is that 22 plus the 28 also equals the 50, which it does. So it works. Now all we're going to do is have a look on this table using our set notation of what each of these cells actually means with regards to the Venn diagram. So looking here, this is actually the football match and the movies. So intersection there, that's our intersection. This one here is the football match and not the movies. This one again is the football match and, or intersection and the movies. And this one is not football and not movies. Now if I was to convert these into probability tables, which I'll do in a minute, these numbers would then be all out of the total 50. So the probability that a student would attend the football match and the movies, so both, is 12 out of 50. So let's just have a look at what each of these cells would produce. If I was to work the probability out, then it would go in there as 12 over 50. All right, so P bracket F intersection M. Obviously I'll write that usually as a fraction or as a decimal. Now if I was to work out all of these, they would all be out of 50. So out of 50, out of 50, out of 50, and so on. So out of 50, out of 50. So what I'm actually now doing is converting this into a probability table. Well, I need to look at what a probability table would total. We know that the probability of any event, the sum of the probability should total to 1. So we know that this should equal 1. This would be obviously the probability of that, and these are all then probabilities of what these would be. Now, over here, this is actually the probability that a student picked at random went to the football match. So this is the probability of F. This one here is the probability that a student did not attend the football match. So that's the notation we've used there. This one's now the probability that a student attended the movies. And this one is the probability that a student did not attend the movies. Both of these should total to 1. And that's always what goes in the bottom right-hand corner of a probability table. I'm going to just run through an example now where we need to know where each part goes in the probability table. So I've got an example. If A and B is such that the probability of A is 0.7, the probability of A intersection B is 0.4, and the probability of A, not A intersection B is 0.2, find these things here. Now, before you find these, I would always set out a two-way table, because that then allows you to find these with ease without having to worrying. Now let's have a look at what we can set this out. So we let this be A and not A here, and this be B and not B. These are going to be our totals, and we know that the probability table should always total 1. So let's fill in what we know. We know that the probability of A intersection B, so it's that one there, is 0.4, and we know that the probability of A, total probability, is 0.7. And we also know that the probability of not A intersection B, so not A intersection B, so that's this one here, is 0.2. We can now go through a process of elimination of filling in the rest of the numbers in the table using the totals. So using a different colour, let's have a look. This is the total here. This is 0.4. This has to be 0.3 because 0.7 subtract the 0.4 is 0.3. Looking at this one, I can total this column here, 0.4 and 0.2 is 0.6. Now I can then go and say, well, this has to equal 1. This is 0.7, so subtract 0.7 from 1, and I've got 0.3. This one here also has to equal 1, so this has got to be 0.4. And now that has to be 0.1 in order for that to total 0.4. Easy now to then work out what these are without thinking too hard. So we want the probability that A intersection not B. A not B, 0.3. We want the probability of B, here's B, total of B is 0.6. Probability of not A and not B is here, so 0.1. And then the probability of A union B, so A or B, well, if we're looking at A or B, we need to consider the Venn diagram. So I'll just have a look at that from a couple of lessons ago, where we used the addition rule. And don't forget, the addition rule told us that when we're looking for A or B, we need to consider the probability of A plus the probability of B, and then we need to subtract that intersection, which was the probability of A intersection B. So let's have a look at that. Probability of A is 0.7, plus the probability of B is 0.6. Take away the intersection, which is 0.4, which works out to be 1.3. Take away the 0.4 is 0.9. And that is everything you need to know about probability tables.